The directions for number 19 say find the derivative by the limit process. I wish the directions said find the derivative by using the definition of derivative. Okay, so that's what they mean by the limit process, using the definition of derivative. All right, so let's go through this one. On 19, our f of x is x cubed minus 12x, and the definition of derivative says that f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x, all of that over delta x. Now, whatever's in the parentheses replaces x. So f of x plus delta x, you go back to f, but instead of an x, every time you see an x, you write x plus delta x instead. So we've got the limit as delta x approaches 0 of, instead of x cubed, it's x plus delta x cubed, minus, instead of 12x, it's 12 times x plus delta x. You see what we've done there? All right, then minus f of x. Well, okay, so minus, and then you put down what f of x is. F of x is x cubed minus 12x. So minus parentheses x cubed minus 12x. And you still got the delta x in the bottom. Okay? You with me? So, what do you call in the third step? All right, let's see. When you cube a binomial, you get the first term cubed plus 3 times the first term squared times the second term, plus 3 times the first term times the second term squared, plus the second term cubed. Yeah, when you cube a plus b, you get a cubed plus 2a squared b plus 2, no, not 2. You get a cubed plus 3a squared b plus 3a squared plus b cubed. That's what you get. All right, then look. Then we've got to distribute that negative 12 times x plus delta x. So you get negative 12x and negative 12 delta x. Then we get to distribute the negative through that last parentheses to get negative x cubed and positive 12x. Do what? Yeah, now it gets fun. So we can do that and that. And I guess that's it, isn't it? So we've got the limit as delta x approaches 0 of 3x squared delta x plus 3x delta x squared plus delta x cubed minus 12 delta x. And now, we've still got that delta x in the bottom, so you're right, we need to factor out a delta x from the numerator. So we have the limit as delta x approaches 0 of, and then factor a delta x from all 4 of those terms. So that'll be delta x. So when we take away a delta, when we divide out a delta x from that first term, we're left with 3x squared. When we divide out a delta x from the second term, we're left with 3x delta x. When we divide out a delta x from the third term, we're left with delta x squared, and divide a delta x out of the last term, and we're left with negative 12. And now we divide out those factors of delta x. I thought it was fun. So now we've got the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared minus 12. Can we substitute? Yes, we can. So that turns into you follow? Yep. So that's 3x squared plus 3x times 0 plus 0 squared minus 12. So that's a 0, that's a 0. I get 3x squared minus 12. Yeah, because it's delta x that's approaching 0. Right, now look, we're finished with the problem. We found the derivative. But now we could find the slope of the tangent line at any point we wanted on this graph. Just all we'd have to do is plug the x-coordinate in. If this function represents the motion of an object, we can now find the velocity at any x we want. The function always represents, well, the derivative always represents the rate of change. We can find the rate of change of f for any x we want. So the derivative that we found is a formula for the slope of the tangent line. It's a formula for velocity. More generally, it's a formula for rate of change, because slope is rate of change, velocity is rate of change. So we've got the formula, and a lot of times that's all we have to do is come up with the formula. But you got to remember what you can do with it. You can now find the slope, you can now find the velocity, you can now find the rate of change. All right, let's move on to more fun, like number 31. It might make you cry. I'm hoping. All right, we're supposed to find an equation of the tangent line to the graph of f at the given point, use a graphing utility to graph the function and its tangent line at the point, and use the derivative feature of a graphing calculator to confirm your results. Wow, that's a lot. All right, so f of x equals x plus 4 over x. That's our function. We're going to find the equation of the tangent line that goes through the point 4, 5. So 4, 5 is on the graph. It will be the point of tangency. So that's where the tangent line goes. So our first order of business is to find the derivative, because the derivative is the slope of the tangent line. All right? So you need to remember, I mean, this is calculus. When in doubt, find the derivative. It won't always be the right thing to do, but it's a pretty good guess, isn't it? So we find the derivative. Our definition of derivative says that f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. I want you to write the next step.
How do we know we don't use the one that has F?
Don't use that unless you have to. Nope. It wouldn't be bad on this one.
This seems like it will. But that's just me.
So write down, you've got the limit as delta x approaches 0, and then instead of f of x plus delta x, you put in what it's going to be when it's f of x plus delta x. And then minus f of x and delta x in the denominator. All right. Can we all agree on what goes in the denominator?
Got it.
All right, we all got that. Now, we have f of x plus delta x. So instead of x, that's f of x, x plus 4 over x. Instead of x, we put x plus delta x. Plus stays plus. And instead of 4 over x, we put 4 over x plus delta x. All right, so then we're looking back here at our definition. Next thing is minus f of x. So minus x plus 4 over x.
Yes. You just solve. That easy. You just solve.
All right. Now, I need to distribute that negative, and at some point, it's one of these things. Math teachers always tell you to show your work, right? And you have to show your work. But we're coming to the point where sometimes we need to do some things in our head because we're just as likely to make a mistake copying from line to line as we are to make the mistake in our head. So you've got to decide what's best for you. Because, when we have these page-long problems, that's a lot of copying from one line to the next. If you're good at that, I'd write down more steps. If you're not so good at that, you tend to be careless, then I start to say leave out a step. It's not that you're leaving out a step, it's just you're doing it in your head. Okay? So you've got to decide what works best for you. Now, I will say this, though. If it takes me 10 steps and it takes you 3, you're trying to do too much in your head. In fact, when I see that on the quiz, my assumption will be you don't have a clue what you're doing. Pretty good assumption on my part, wouldn't you think? Okay. So, here's what I'm going to do. I've got a positive x up here. Well, let's put it this way. I need to distribute that negative. Makes that a negative x and a negative 4 over x. If I know that that's a negative x and I've got that positive x up here, that's a 0, isn't it? Okay? So I don't really need to write down a step just to do that 0.
Whoa.
So, that and that give me a 0, so I copy down the delta x, I copy down the 4 over x plus delta x, and I copy down the 4 over x, but it's not really a 4 over x, it's really a negative 4 over x. And we still have delta x as our denominator. All right, now, keep in mind what we have to do before we can actually find this limit. We have to get a factor of delta x in the numerator to divide out with our delta x in the denominator. Okay? I can't get a factor of delta x in the numerator until I get rid of these fractions. They make sure I cannot simply factor out a greatest common factor of delta x. Fractions mess me up. So I'm going to get rid of them. What do I need to multiply by to get rid of those two fractions? That, right? Isn't that the least common denominator? That's the two. Well, even if it's not the least, it's a multiple of those two denominators. It's going to work, and it is the least. But you with me? So if you do that to the top, you got to do it to the bottom. All right. So here's what happens when we do this. I have to, and so do you, distribute that. I've got to multiply what I just circled times delta x. And when I do, I get delta x times what I just circled. Then I got to multiply what I have circled times 4 over x plus delta x. Now here's where it gets fun. Because if I'm multiplying what's circled times 4 over x plus delta x, can't I divide out the x plus delta x's? And so now I just have 4 times x. Now, that's not divided out anymore, is it, for the next term? So now I've got to multiply what's circled times negative 4 over x. Well, that x divides out with that x. So I get negative 4 times x plus delta x. So negative 4x minus 4 delta x. Now, that's an easy place to mess up, isn't it? So be careful. Did everybody follow me on that one? All right, so let's see what happens here. I've got a positive 4x and a negative 4x. That gives me a 0. I like that. Notice I did not multiply anything out in the denominator. Because now I've only got 2 terms left in the numerator. I've got that and that. Okay, you see what I've done? And do you see how we're in really good shape now? Because I only have 2 terms left, and those 2 terms both have a factor of delta x. So I can factor the delta x out of those 2 terms. Now, it's important that you're with me, because this kind of algebra is going to come up a lot, and it's kind of complicated. We good?
Yeah.
All right. So, from the numerator, factor out your delta x.
No, cancel.
All right, you see what I've done? I just factored the delta x out of both of those terms in the numerator. Now, we get to divide out our factors of delta x. Can we substitute now?
Yeah. No.
We can. It won't make our denominator equal 0, so we can substitute now. So everywhere you see a delta x, replace it with 0. So that first parentheses, instead of being x plus delta x, it's now x plus 0, which is x. All right, I put the 0 there, so I get x in that parentheses times the other x minus 4. In the denominator, when I put the x in for delta x, that first parentheses is now x, and then times the other x. You with me on the substitution? So we get x squared minus 4 over x squared. Well, let's hang on.
You're not even.
Yeah, we're close. We're real close.
And that's the end of step 1.
No, not yet, it's not. We're not through with step 1 yet. Now, a lot of times our book will write the answer like that. You see what they did? I don't particularly like it that way, but what they did, and I'm struggling without my pen to do this, is they took the x squared minus 4 over x squared and wrote it as x squared over x squared minus 4 over x squared, and then that becomes a 1. I'm not real fond of it either, but the book does that quite often. All right, so I'm going to keep it as x squared minus 4 over x squared. Okay? Now, what are we trying to do? We're trying to find an equation of the tangent line. What we have now is a formula to find the slope of the tangent line. So let's find the slope of the tangent line. They gave us the point 45. So at the point 45, f prime of 4, why did I call it f prime of 4 instead of f prime of 5? Because 4 is the x-coordinates. F prime of x, use the x. And then you substitute a 4 in for x. So 4 squared minus 4 over 4 squared. So that's 16 minus 4, which is 12, over 16, which reduces to 3/4. And that is the slope of the tangent line at that particular point. How come the 5 didn't come into play? But yeah, it's the y value. It's not in the formula. All right, we've got the slope of the tangent line. We still don't have part A finished. We still don't have the equation of the tangent line. But we know the slope is 3/4. We know that the line goes through the point 45, so we can use the point slope form of an equation of a line. So the slope of the tangent line at the point 45 is 3/4. So use y minus y1 equals m times the quantity x minus x1 and substitute in. So that's y minus, and then y1 means the y coordinate of your point, so y minus 5, equals m, that's what we spent all the time finding, m is the slope, 3/4, times the quantity, x minus, and then x1 means the x coordinate of your point. Now, they don't tell us what form to put the equation of the line in, but almost everybody likes it in the y equals mx plus b form. That's never a bad idea, okay? So, let's distribute the 3/4 on the right. That gives us y minus 5 equals 3/4 x minus 3. Then we add 5 to both sides. And that's our equation of the tangent line to the graph of f of x at the point 4, 5. And we are now finished with part A. Any questions? All right, part B. Use a graphing utility to graph the function and its tangent line. All right, so y equals x plus parentheses 4 divided by x, close the parentheses. All right, I graphed f of x. And then they want us to graph the tangent line, which we found to be y equals 3/4 x plus 2. And there we go. And it's kind of hard to tell with that window exactly where the point of tangency is. So look, let's do this. Let's trace. All right, I'm on the function here first. Oh, it's not going to get me the right decimal, is it? It's whatever the standard is. So you can see that 4, 5, I'm really close to having 4, 5 on there. Then if I switch to the line, see it's really close to 4, 5. So I'm bad at setting the windows to get exactly what I want. But you can see that if I knew how to set the windows, I could go back and forth and get the point 4, 5 is on the line, and it's on the graph, and it's where they intersect. Okay? All right. Now, part C. Use the derivative feature of a graphing utility to confirm your results. So let's see if I remember how to do this. I'm going to quit that. I'm going to go to second calc. And I'm going to choose number 6 for me, dy dx. That's one of our notations for derivative, isn't it? All right. Now, I need to make sure I'm taking the derivative of the f of x, not of the line. Okay? So see how y1 is showing up here in the corner? So I'm on y1. Now I want to find the derivative when x equals 4. So I think I can just do 4. Yeah, that does it. So just hit 4, and that changes it to x equals 4. No, that's not what I'm supposed to get. You got 5? How come everybody got 5 but me? So then I choose 4. Huh. Why aren't I getting? Oh, I'm getting the right thing. Because the derivative is the slope of the tangent line. And what did we find to be the slope of the tangent line? 3/4. So that's my calculator's effort at getting 3/4. Okay. Whew, I was doing it right. So what all y'all do wrong? Calc. Yeah. Be on Y1. All right, so look. Your calculator will compute the derivative at any x coordinate you want it to. But it won't get, well, at least these won't give you the symbolic derivative. There are some that do, okay? I remember taking a graduate course in 1986 probably, and the professor was big into computer science as well, and he was completely convinced that they would never be able to do derivatives on a computer and get symbolic answers because it's just too difficult. Well, now they do, and it's not difficult. Okay, you can probably find a program online that will do that. All right. What's it called? And I'll think of it when it's too late. But there's a place you can ask. Wolfram Alpha. I'll bet you they can do it. I guess anyhow. All right. So that's how you use your calc. That's something the AP test requires you to be able to do. Is to find the derivative, the numerical derivative of a function at a given x coordinate on your calculator. And that's what we just did. We found the numerical derivative of that function at the point where x equals 4. Okay? The derivative is the slope. All right. Is your head full?
Whoa! Yeah.
And don't try to spare the paper. Use the paper up. I'll give you more if you need. If you run out, I'll give you some.